Hi everyone, welcome back. So this is the second lesson, which is on the theory of interest. So today we'll be focusing on these two parts. This is the effective rate of interest and effective rate of discount. Okay, what is effective rate of interest? Usually, interest rate vary within a period. So we want to measure the average interest rate for that period. So the period that we are talking about right now is annual, but it can be any period, right? Like monthly, quarterly, yearly. But now we are focusing on a year. So the average is called effective rate of interest, and then it's notated as follows: IT, and that T means it is the effective rate of interest for the Tth period. So for example, if we write I2, it means it is the effective rate of interest for the second year. And bear in mind, the Tth year will range between time T minus 1 and T. For example, for the second year, right, it will range from time 1 to time 2. First year, it will range from time 0 to time 1, right? Okay. So, how do we calculate this effective rate of interest, IT? We can use accumulation function or amount function. So if we use the accumulation function, it will be the accumulation factor at the end of the period minus the accumulation factor at the beginning of the period divided by the accumulation factor for the beginning of the period. Also, it can be the amount at the ending of the period minus the amount at the beginning of the period over the amount at the beginning. So in other words, it is the interest earned in the period, the interest earned within the period. So ending minus beginning is the interest earned, right? Over the amount in the beginning of the period. So it is quite intuitive. Basically, it's the effective growth rate lah. So let's see, for example, I can illustrate to you. If just imagine this chart to be the amount function instead of the accumulation function. So let's say at the ending period, the amount is 105. Beginning period, the amount is 100. So then IT is going to be 105 minus 100 over 100. So it's 5%. So if again, effective rate of interest is the average for that period, and also it won't reflect the ups and downs within the period. However, I just want to highlight that usually in your questions that you will find later, it will specifically just mention that the effective rate of interest is such and such, and usually it is automatically assumed that the rate of interest within that period also is going to be that same constant rate, because unless it is stated otherwise, technically when we say effective rate of interest, it could mean that the rate within is not going to be the same as the average, right? It can be varying. However, in our problems, if we are given the effective rate of interest, usually we assume within also it will be a fixed rate. So with that assumption, actually the progression should be like the exponential growth like we used to see, a smooth curve, not like this. Just a note for you in that sense. Yeah, but in reality, you just need to know that the effective rate of interest only take into consideration the beginning and the ending value. It totally ignores the ups and downs within that period. Okay, moving on. Okay, if we reshuffle the equation just now, we will get it in two forms. The first one, the second one. The first one will be the ending amount is equals to the beginning amount plus beginning amount times I, which is, this is technically just the interest earned in that period. So the ending amount equals to the beginning amount plus the interest earned. Okay, and the second, we will get ending amount is equals to the beginning amount times 1 plus IT. So from the second equation above, you can see that our ending value is dependent on our beginning value times 1 plus IT. So when we times, we are basically accruing interest to our beginning value. And our beginning value technically can consist of the original principal amount plus any amount, any interest that have been accrued in the previous periods. So yeah, ending value is dependent on the beginning value, and the beginning value can include these two components. So by doing this, I'm saying that the effective rate of interest concept, it jives with the compounding interest structure. So due to this, if we want to compute the effective rate of interest for the second year, third year, fourth year, it will be the same. This value will be the same as the compounding interest I. But this is not the case if we look at the simple interest structure. Okay, so compound interest with constant I, this is the accumulation function for the compounding interest scenario. So in this situation, if we want to find the effective interest rate for the first year, second year, third year, and so forth, this effective rate of interest is going to be a constant value, and that constant value is this I. So it's constant in this scenario. But for this scenario, if we want to find the effective rate of interest for the second year, the third year, the fourth year, it's not going to be a constant. It's going to be either increasing or decreasing. We will find out later. Why? Okay, this is how we calculate the effective rate of interest, right? The interest earned over the amount in the beginning of the period. So the interest earned in a simple interest case is going to be a flat amount, fixed amount. Every single period, the increase is the same. So the numerator is flat, but the denominator, beginning value, keep on increasing. So since the denominator is increasing, the effective rate of interest will decrease. So it will be a decreasing pattern. So the answer is it will be decreasing. So IT is not equals to the I in the simple interest, especially for the second year, third year. The first year it will be equivalent, but the year after this first year is not going to be equivalent. Okay, let's see an example. We have an investment where it follows a simple interest of 4%, and we need to find which period will have an effective rate of interest that is equivalent to 2.5%. So we know for a simple interest, the first year, the effective interest will simply be the I of the simple interest will be 4%, but eventually it will keep on dropping. On which year will the effective rate of interest, IT, will be equals to 22.5%? So we need to, first, you need to determine the equation for the IT for simple interest. So the simple interest is technically the interest accrued in year T. So interest accrued, technically for year T is going to be like this, as follows. C, the principal amount, times I. So that is the interest accrued. For every single year is a flat C times I. But the denominator, the beginning value, the beginning amount, the amount at the beginning period is going to be C times 1 plus I to the power of, not C, 1 plus I times T minus 1. Because we want to find the value at T minus 1. So it's times T minus 1, right? If we find the average value for time T, it will be 1 plus I T. But this one T minus 1, so this one is also T minus 1. So if you simplify this equation, then you'll get as such. So now you will find the T that makes this equation. So equals to 2.5%. So then you will get T is equals to 16. Okay, we will stop here for this part. See you in the next video.